Let's solve a quadratic inequality. I have x squared minus 2x minus 35 is less than or equal to 0. I'm going to solve this two ways. First, I'm going to solve this by using the sign graph. Now the sign graph is just a lot of positives and negative signs. And then I will graph this in my calculator and we will determine the answer using the graph. To solve this by the sign graph, I will get everything on one side. I will factor it just like I would a quadratic equation. And then I will solve a quadratic equation to find my boundary numbers. After that, I will place these boundary numbers on a number line. I will place the binomials on the left side to help me with my sign graph. And then I'll pick test values in each area, in each interval, to determine if it is true or false. So let's begin by factoring this. This will be x minus 7 times x plus 5. And then I will solve this as if it was an equation. X minus 7 will equal 0, which means x will equal 7. Or x plus 5 will equal 0, which means x is negative 5. So these are my boundary numbers. So we need to take these numbers and place them on our number line. Make sure you put these boundary numbers in the correct order. This is a number line. And then I'm going to take my binomials, x minus 7 and x plus 5, and I will put them to the left of my number line. And we are going to fill in each of these sections with positives or negatives. Let's get to work. So pick a number between negative infinity up to negative 5. Any number. Oh, let's try negative 10. This is my test value that I'm using for this interval. I'm going to plug this number into each binomial and determine if it's a positive number or a negative number. Negative 10 minus 7 is negative 17. But now remember, I don't care about the number, just the sign. Negative 10 plus 5 is a negative 5, which is a negative. So in my first section, interval, negative infinity up to negative 5, my first binomial would be a negative times a negative. That section, my answers are all going to be positive because a negative times a negative is a positive. Let's pick a test value between negative 5 and positive 7. And we can use 0. 0 minus 7 is a negative number. 0 plus 5 is a positive number. I would have a negative times a positive. That will give me a negative answer. The last interval from 7 to infinity. Pick any number. Oh, let's try 11. If I plug in 11, in my first binomial, 11 minus 7 will give me a positive number. 11 plus 5 would give me a positive number. And a positive times a positive is a positive. Now go back to your problem. Which answers did you want? I wanted mine to be less than or equal to. And if it's going to be less than or equal to, that means it's going to be a negative number. So I want this section, this interval, from negative 5 up to 7. Now it did say less than or equal to, so that means I will include negative 5 and 7. How do I write this in interval notation? It will be a bracket and the interval starting and including negative 5 and going to positive 7. Now, let's do the same problem by using our graphing calculator. I would get this parabola. It does cross the x-axis at negative 5, which was a boundary number, and at positive 7, which was a boundary number. Now notice, from all the x's from negative infinity up to negative 5, my graph, my y's, are above the x-axis. They're positive. And then from 7 to infinity, the graph is above. Those answers from negative infinity to negative 5 and from 7 to infinity are greater than or equal to. They're positive. But remember, we wanted negatives. So we want to look at this part of the graph that is below the x-axis, where my y's are negative. So if I wanted to divide these up into sections, so yes, we know that it crosses the x-axis at -5, and it crosses the x-axis at 7. And so do I want negative infinity to -5? Or would I want -5 to 7? Or the last section would be 7 to infinity. And yes, as you see, I wrote -5 to 7 is the interval of numbers that we want, because that is where our graph is below the x-axis. They are less than or equal to.